Okay, I'm back for a final shot, and it's 5.2. And we've got a nitrate pollution problem among a bunch of countries located along a river, from upstream to downstream. So here's the river, and we've got country 1, 2, 3, N. Okay. Each country I enjoys a benefit, B, which is 10 EI minus a half EI squared. So B is 10 E minus a half E squared, and that's the same for each country, so we can add the i's but nothing changes. It applies for all the countries. They all have the same benefits from emissions. But let me see. We've got 10 up to 10 countries. I is less than J means country I is upstream of country J. Okay. So let's say 1, 2, n minus 2, n minus 1, n. And the river's getting more and more polluted, isn't it? As we go downstream. Okay. Marginal damages are 1. That's marginal damages. But this is total benefits, isn't it? So we need to be a bit careful here. So find the laissez-faire levels of pollution. Each country enjoys a benefit from emitting units of wastewater. Each country discharges waste downstream, so will only suffer from pollution emitted upstream. So in laissez-faire, the countries won't care at all about their emissions, will they? They will just maximize B. So they will maximize by choice of E. B is 10 E minus a half E squared. So the first order condition will give us that E equals 10. And time for a quick pause. Yeah, so I guess we should stick in our answer to the notation in the question, so we should say EI equals 10 for all I. Okay. Part B. Find the efficient levels of pollution. Okay. So, how are we going to do this? So let's put that to one side. EI equals 10 in the in laissez-faire. Now, let's make it concrete and consider country N. So we're going to have to consider the countries one by one, I think, in principle. So let's just think about country N. Okay, no, because N is down here. I want to consider the most upstream country. So let's consider country 1. Okay, so the planner, what is the planner then maximizing? The planner wants to maximize social benefits, we can call them B or whatever, by choosing EI. And the social benefits B are the private benefits of country 1 minus the damages. And what are the damages? Well, there's no decay of the wastewater, is there? So all these other countries are going to suffer from this unit of emission, or from these emissions. So there's N-1 countries are going to suffer. And how much are they going to suffer? The marginal damages were just 1, weren't they? So they're going to suffer in exact proportion to the emissions. And note that this is crucial, that these damages, marginal damages, are constant. They don't change with emissions. If they did change with emissions, the problem would be much more complicated, because we wouldn't be able to calculate country 1's optimal emissions without knowing the emissions of the other countries, because those emissions are going to affect the damages caused by country 1 if they're changing on the margin. So then we'd need to set up a problem with all the countries at the same time. It would be a massive problem. You'd need a computer. You'd need to solve it, in MATLAB or in GANS or something. But here we can solve this quite straightforwardly. I'm pretty sure this is the correct. So let's take the first order condition, which is going to give us that 10 minus n minus 1 equals 2 times a half is just E1. So E1 is 11 minus n. And we'll take a wee breather there. Okay. This is all very well, but do we really want to do this over and over again for each of the countries? No. So let's just park that answer. E1 is 11 minus n. And see if we can do something more general. So actually, I wrote EI here, but it should have been E1 and E1, shouldn't it? But what I'm going to do now is actually say, well, what about country I? So far so good, but it's here we need to change things, isn't it? Because this is no longer n minus 1. How many countries are getting affected by country I's emissions? It's n minus I, isn't it? If I equals n, this is 0. No countries are getting affected. So, this is more like it. Now when we take the first order condition, we get 10 minus n plus I equals EI. So EI is 10 plus I minus n. And of course, when I is 1, we have 11 minus n, which is what we found earlier. And if, for instance, n is 10, what do we get? Then country 1, n is 10, we have 10 minus 10. So E1 is 1, E2 is 2, E3 is 3, and so on. In the social optimum. Why is this? Well, of course, the damages are greater. The further upstream you're emitting, the more damages you're causing. It's pretty straightforward. So what would the fair contribution to a common fund compensating for the total damage be? Well, I guess, I mean, isn't it n minus I? That's the damage you're causing, isn't it? Is that right? So if n is 2, then damages, total damages, if n is 2, then country 1 is only affecting country 2. So emissions by country 1 are 10 plus 1 minus 2 is 9. Country 1 will emit 9, cause damage is 9. Nah, so this isn't right, is it? I need to have a think. Okay. So for once, my crib sheet seems to be wrong. I don't know. I did the crib sheet myself as well, so it's not somebody else's work this, but n minus I is the number of countries affected by country I's emissions, isn't it? But the total damages caused by country I's emissions are n minus I times EI. So if you had a sort of liability rule, then that would be the compensation, wouldn't it? And of course, that's exactly what we see here. So if you had to pay that compensation, that would give you optimal incentives, of course. If you have to pay your damages, you will have optimal incentives. Okie doke.